In this video, we will write equations for lines based on the descriptions given. In doing so, we'll review the slope-intercept form of a line, the point-slope form of a line, as well as horizontal and vertical lines, and the equations for them. Note that this example has 5 parts, and parts D and E will be covered at the end of the video. Alright, so let's get started with this first one. We're asked to write an equation for each line described, and this first one, part A, says a line with a slope of 2/7 and a y-intercept of the point 0, -3. So we are given the slope, we're given the y-intercept. We want to use then the slope-intercept form to write this equation. And that slope-intercept form is y equals mx plus b. And so from this information, we see the slope is 2/7 and the y-intercept is 0, -3. So we can identify that m is going to be 2/7 and b will be the number -3. So when we write that equation, we will have y equals 2/7 x plus -3. And when we simplify that, we would simply write y equals 2/7 x minus 3. Okay, for this next example, part B, we're given a line with a slope of -10 that passes through the point 2, 9. So we're given the slope and we're given one point. That point is not the y-intercept, so we're going to use the point-slope form. And the point-slope form is y equals m times the quantity x minus x1, so x minus x1 are in parentheses, and then we add y1. And again, x1, y1 is referring to the specific coordinates of one point. So this 2, 9, that's our x1, comma y1. That's our specific point we're given. And our slope, that's m. And so that's -10. So we know that m is -10, and we know our point is 2, 9. So when we write that, we will have y equal to -10 times x minus 2 in parentheses, and then we will add 9. This is an equation that represents that line. In general, we simplify it to slope-intercept form, so it's everything that has been expanded, distributed, combined, has been. So to do that, we'll distribute this -10 across that expression x minus 2, and that will give us y equal to -10x plus 20, and then we still have plus 9, and our final step of simplification would be y equal to -10x plus 29. And again, that's the simplified form. Okay, this next one, part C, we are given that a line passes through the points 2, 12 and -4, 18. So we can't immediately write our equation for this, but what we'll want to do, since we have 2 points, is to first calculate the slope, and then use the point-slope form. So let's do step 1. We have the points 2, 12 and -4, 18. So our slope, m, when we're calculating that from 2 points, we write that as y2 minus y1 in the numerator divided by x2 minus x1 in the denominator. And again, we're just subtracting the coordinates, those y coordinates, and then dividing that by the subtraction of those x coordinates. So we'll have 18 minus 12 in that numerator, and then -4 minus 2 in that denominator. So that numerator will simplify to 6, denominator will simplify to -6, and we'll have -1. Now we'll go on to writing that equation. And our general point-slope form, we have y equal to m times the quantity x minus x1 plus y1. And when I used these, I made 212 x1, y1, and negative 418, x2, y2. But when we use this point slope form, we can use either of these points. So I'll do it first with that point 212. So I'll have y equal to, and my slope is negative 1 that I just calculated, so y is equal to negative 1 times the quantity of x minus 2 plus 12. And so that is an equation representing a line that passes through these points. If I simplify it, I'll get y equal to negative x plus 2 plus 12 when I distribute that negative 1 across the expression x minus 2. And then in one more step, I can write that as y equal to negative x plus 14. Just as an example, I'll show what would happen if I use that second point. So if I use the second point, I would get y equal to negative 1 times the expression x minus a negative 4 plus 18. So I'll have y equal to negative 1, and I'll simplify what's inside those parentheses. I'll have x plus 4 inside those parentheses, and then plus 18. So y is equal to negative x minus 4 plus 18, and in that final step we can see y is equal to negative x plus 14. So the simplified form makes it really easy to see that this is exactly the same line. These first two that I had are both equations representing a line that passes through both of those points. Okay, now we'll move on to parts D and E. And so for part D, we're going to write the equation for a horizontal line through the point 0, negative 9. So I'll just draw a sketch of a horizontal line real quick. I won't even scale this, I'm just going to give a visual of a horizontal line that would go through 0, negative 9. So it's horizontal, and it'll look like this, and it would go through the point 0, negative 9. So in general, a horizontal line is y equal to some constant, and for this line, it will be y equal to negative 9. And what that's showing is that the value of y is negative 9 regardless of what the value of x is. We see that there's no x in that equation. That means that for any x, the y value is going to be 9, and that results in a horizontal line. For the last one, we'll do a vertical line passing through the point 8, 0. So again, I'll do a quick sketch of what this would look like. And it'll be a vertical line, and it'll go through the point 8, 0. So I'll just draw that out. I'm not going to scale it. I am going to mark off the point 8, 0 just for my visual. And so I see that vertical line, and in general, a vertical line is given by x equal to some constant. I'll write x equals b. And this constant that we have here is 8. So x is equal to 8 is the line, or the equation of the line, that represents a vertical line going through the point 8, 0. And again, we don't see y in this equation, so x is equal to 8 for any value of y there.